There is a second capability that Oracle provides that is very useful for tuning SQL statements, and that is the Autotrace capability. This feature is available both in SQL Developer and SQL+. The output in each one looks a little bit different, so I'll demo its use in each tool during this section. The most important difference between generating an execution plan and using the Autotrace feature is that when you run a SQL statement using Autotrace, Oracle will actually execute your SQL statement. So if you have any DML statements that you're testing, be aware of this and be prepared to roll back your transaction or restore your data in some fashion, because this DML statement will run. Likewise, if you have a very expensive query you are running, that statement will run, so you will be consuming system resources on your Oracle database server. For this reason, it's usually best to confine the use of the Autotrace feature to your test environments. What is useful about the Autotrace capability is that Oracle will report back to you a number of statistics from the execution of that SQL statement. For tuning of SQL statements, the most interesting values that come back are the number of logical and physical IOs. In addition, you will also get some statistics around the number of sorts performed, both in memory and that would require the use of disk, and some information on the number of packets needed to be sent over the network. Let's review for a moment the concepts of logical I/O versus physical I/O. When your SQL statement needs to read a block of data, and that block of data is already in the buffer cache, this results in a logical I/O operation. That is, Oracle is just reading the block from memory. When your SQL statement needs to read a block of data that is not in the buffer cache, Oracle first has to read the block of data from disk into the buffer cache, and this is a physical I/O operation. Then Oracle will read the block of data from the buffer cache in a logical I/O operation. So in this case, the result is both a physical and logical I/O operation being performed. The I/O operations occur anytime Oracle needs to read a block of data to process a SQL statement, regardless of whether the block of data is part of an index or part of a table. What the number of I/O operations give you an idea of is how much data Oracle is having to read and process for any given SQL statement and for each step in a SQL statement. Now you will also see the term consistent get used throughout the Oracle documentation. The term consistent get is synonymous with the term logical I/O. Historically, Oracle has tended to use the term consistent get more often, but over the last few years, we've started to see the term logical I/O used more often with Oracle. Just know that these two terms refer to the same thing. In the example that we are getting ready to do, we'll see that the metric is labeled consistent gets, so don't be confused by this. Now that we are straight on terms, what does all this mean in terms of tuning our SQL statements? What we really want to look at is the number of logical IOs or consistent gets that our statement is performing, and as we tune our statement, we want to see this number go down. Reducing the number of logical IOs means that we are reducing the amount of data that Oracle needs to process in order to process our SQL statement. Quite simply, processing an array of 1 million elements is going to take a lot longer than processing an array with 1,000 elements. And the number of logical reads gives us a good feel for the amount of data that our statement is having to process. So if we can do something like write a more restrictive where clause, introduce an index, or modify an index to be more selective, we're going to cut down on the amount of data Oracle has to process, and this will show up as a reduction in the number of logical IOs. Now you might be thinking that we want to reduce the number of physical IOs, especially since reading from a block of disk is several orders of magnitude slower than reading a block from memory. And this is true. We do want to reduce the amount of physical I/O that Oracle has to perform for any statement. However, by reducing the amount of logical I/O, we will inherently be reducing the number of physical IOs as well. The fewer blocks our statement needs, the more likely it will be that those blocks will already be in the buffer cache. And if we do need to go to disk, it will just be to read the few blocks that are necessary, not to read an entire table of data.